Google just shipped a multimodal model with the encoders ripped out. Every other model on the planet needs them to see and hear. Gemma 4 doesn't. And somehow it got better, not worse. Here's what we're getting into. Why every multimodal AI is built around encoders, what it actually costs to keep them, and the one architectural trick that let Google throw them away and run it all on a laptop. First, what actually dropped on June 3rd? Gemma 4 12B runs entirely on a laptop with 16 gigabytes of memory. No cloud, no API bill, the whole model sitting on the kind of machine you probably already own. It's 12 billion parameters. Open weights, Apache 2.0 licensed. So you can download it, ship it, fine-tune it, whatever you want. And it doesn't just read text. It sees images, listens to audio, and watches video. A near-frontier model that fits in a backpack. So, that's new. But here's the thing. The size isn't the headline. Plenty of small models are multimodal and kind of mediocre. What matters is how Google made this one good. And that's an architecture story, not a size story. So, how does a model normally learn to see? Here's the standard playbook. An image hits a separate vision model first, an encoder, that turns pixels into something the language model can read. Sound gets its own encoder. Then both translations get handed to the actual brain. 3 models, taped together. Think of an encoder as a translator at the border. The model only speaks tokens. Pixels and sound waves don't. So each one gets its own translator at the gate, converting before anything's allowed through. That convenience has a tax. You're now loading at least 2 extra models into memory, just to handle tensors. More memory, more latency, before the model has a single thought. Google's words, not mine. Encoders add latency and cost memory. So that's the deal every multimodal model signs. Want senses? Pay the encoder tax. For years, that felt non-negotiable. Then, in June 2026, Google just stopped paying, and the model came out ahead. Here's the part that actually matters. Watch what's missing. No vision encoder. No audio encoder. The image runs through a tiny conversion layer and drops straight into the same model as your text. One brain. No translators at the gate. How small is that conversion layer? About 35 million parameters. For vision, it's basically one matrix multiplication, plus a little cleanup. They didn't shrink the translator. They replaced it with a rounding error. Audio's even wilder. There's no audio encoder at all. The raw sound signal gets projected directly into the same space as text tokens. The model treats a sound wave like just another word. Same brain, new sense, 0 extra machinery. So, that's the trick. Not a smaller encoder. No encoder. Delete it, and replaced by a single matrix multiply. That's how a 12 billion model learned to see, hear, and watch video without ballooning in size. Okay, but does the thing actually perform? Here's Google's claim, and it's a bold one. This 12 billion model lands near their 26 billion model on benchmarks, at less than half the memory. Half the footprint, almost the same scores. If that holds up, it's a little ridiculous. On GPQA Diamond, a graduate-level reasoning test, Gemma 4 12B reportedly scores around 79. Google says that beats the older Gemma 3 27B, a model more than twice its size. The exact figure isn't officially confirmed yet, so hold it loosely. It's also quick for its size. Gemma 4 ships with a built-in draft model that guesses several tokens ahead, then verifies them, so it's faster, with no quality hit. Add a 256,000 token context window and over 140 languages, and it's clearly built to run agents, locally. Want proof it's real? In one demo, the model chewed through a 5-minute video, 313 frames, plus the audio track, and understood all of it. Exactly the kind of multimodal work it's built to run locally. So, add it up. A 12 billion model doing near 26 billion work. Seeing, hearing, watching video, running offline on a normal laptop. The encoder tax that everyone paid for years? Gone. Quick recap. Multimodal models normally bolt on separate encoders to see and hear. Those encoders cost memory and speed. Gemma 4 deletes them, swapping the vision encoder for a single matrix multiply and projecting audio straight into the model. The result, per Google, nearly matches a model twice its size, on a laptop. Want to run it yourself? It's on Hugging Face and Olama now. Links in the description. I'm testing it head-to-head against the 26B model next. Real tasks, not just benchmarks. I put out a new breakdown every day. Subscribe and the next one will be waiting.